Hey there guys, in this video we're going to continue our discussion of the level of significance, and what we're going to do in this context is we're going to consider two examples, and I'll show you exactly how the rejection region approach works in tandem with using p-values. So we'll run the hypothesis test as normal first, and then I'll show you how the rejection regions work. So it might be a good idea, since this is so long, at least the description of the problem, to just pause the video and give it a read yourself and maybe get the hypotheses, and then we'll pick back up. Okay, so hopefully you've read the problem over, and what we'll do now is we'll start with the steps to the hypothesis, which in this case are the null and the alternative. Okay, now if you read carefully in the problem, this is dealing with means. Okay, very easy to see that. So the variable in question here is going to be mu, and the number in question, the number of years, is going to be the 26.5. That's what's describing the parameter in this case, the population. And then we need to make a decision about what is the testing hypothesis. And so in this case, this researcher wants to see if the mean amount of time is going to be less than 26.5 years. And so for those reasons, we have to treat the alternative as less, and then the null, of course, could be equal to or greater than or equal to. Don't maintain. Okay, that's all well and good. Now step number 2 is to get the test statistic. Okay, so we've got some computation to do. So we've got that formula off of our formula sheet, the z equals x bar minus mu over sigma divided by square root of n. So you have to obtain that information. So these guys conducted a study, and they found the mean average to be 26. So that's the sample, minus 26.5, which is our mean. Standard deviation was provided as 2.3. And we divide that by the square root of the sample size, which is 213. Okay, and so if you punch that into your calculator, you're going to get negative 3.17. So remember, that is our test statistic. Okay, step number 3 is, of course, to obtain our p-value. So we're looking here for the probability that our sample mean is less than negative 3.17. Okay, so the reason it's less than is, remember, that's coming right from the alternative hypothesis. Okay, so just a quick picture of our normal distribution. So negative 3.17 is somewhere way over here, and that's the area under the curve, very, very small. So looking up the normal distribution table, you want to pause the video, that's fine, and look it up, and you're going to end up with 0.0008. Okay, so that again is our p-value. Step number 4 is to obtain a decision here. And so remember, to do that, you compare the p-value versus the level of alpha. So the p-value here was 0.0008. Okay, now, if we go back and read the problem, they didn't give us alpha, right? That wasn't reported. But what we were told is a 99% level of confidence. So what you have to remember is that alpha is equal to 1 minus c. Okay, so that's actually going to be an alpha of 0.01. Okay, so a little sneaky there in how they wrote that problem. So don't be surprised if that comes up. Okay, so we give you a level of confidence, you can find alpha. And very clearly, you see that it is less. And so in this case, we will reject the null hypothesis. Okay, and then in the step number 5, we would state the conclusion. We'll do that in a second. Let me just pause here, because what I want to show you next is how this would work with rejection regions. Okay, so with the rejection region, we don't deal with step number 3. We don't get a p-value. Instead, what we do is the following. Okay, so this would be a new step 3. So this would be the rejection region. So here's how this works. Okay, it says we need to get a normal distribution picture, all right? And because the alternative is mu is less than, okay, and our corresponding value here is going to be area to the left, we need to figure out what the z alpha value is. And if you remember, we had a chart for that. Okay, so let me just go back here. Here's the chart. And so what we're looking for is the level of confidence to be 0.99. Therefore, the one-tailed test that I'm dealing with, that z alpha level, is going to be, the Z alpha level is going to be 2.33. So that's what we're looking for to study in this particular example. Okay, so let's go back. So that means that this value is going to be, should be negative 2.33. Negative 2.33. And so as a result, let me get another color here. Whatever's in the blue, this is the rejection region. And so what we're looking for, what we're hoping, is that my test statistic falls in this blue area. That's the rejection region. What you should notice is that's negative 3.17. That is going to be somewhere over here, isn't it? Isn't that going to be somewhere over here in our rejection region? And so as a result, we will reject the null hypothesis, okay? And so this area would be 0.99 if you're looking to study or understand the areas under the curve, and then 0.01. Okay, that's how we're obtaining that 2.33. A little bit of chapter 6 there. Okay, so I hope that makes sense in looking at this level of significance. So people say, well, I'm not really sure about this rejection region. You don't have to use it. You can use the p-value, but the typical one that is used in some of the higher level statistics is looking at the rejection region by comparing the test statistic to this Z alpha level. Either way you spin it, we do have to have a conclusion here, which means we have to answer the question. And so the question here is determine if there is sufficient evidence to support the researcher's claim, and there is. Okay, so at the alpha equals 0.01 level of significance, there is enough evidence to support the researcher's claim. Okay, and so that's an example of using this sort of rejection regions in this context. Okay, let's continue that discussion and that notion, and let's look at this particular problem. Actually, let me go back for just a second. Sometimes people wonder, well, how would this work if it was an area to the right? It would work exactly the same way, only the blue region that I've got shaded here would simply be on the right side of the graph. So it's the same exact idea. Okay, so nothing unusual there. So once again, I encourage you to pause the video and read this over, and then we'll go ahead and take a look at how to work the problem. Okay, so hopefully you've had an opportunity to read this over. So this is dealing with fertility rates for women in Europe. And so the first part to this is to obtain our hypotheses here, okay, both the null and the alternative. And fortunately, we are dealing with means again, so mu is going to be with us. And we are told that the parameter in this case is 1.5, okay, 1.5 children. And the research hypothesis here is they're looking for a mean fertility rate that's different from the mean from all Europe. And so that is not equal to, and therefore the null has to be equal to. So we're dealing with a two-tailed test. Okay, no big deal. Now let's go ahead and run the computation for the test statistic. So it's the same exact formula that we had before. So if you need to reference that on the other slide, you can rewind the video. Our sample mean here is 1.4 minus the parameter of 1.5. The standard deviation we had was 0.8 divided by the square root of 128, which is the number in the sample size. And so this gives us negative 1.41. Okay, so once again, that is our test statistic. So the next thing we have to do, okay, is if we were doing a regular test, is we would deal with the p-value. Okay, so this would be 2 times the probability that z is less than negative 1.41. So you have to remember how two-tailed tests work. Okay, so you've got negative 1.41 and 1.41. And so we are looking for the area here under both tails, okay, under both tails. Okay, so we go to the normal distribution table, and what you should find is you can look up the negative 1.41. You're going to get 0.0793, and we multiply that by 2 since it's two-tailed, and we end up with 0.1586, and therefore we move to step 4, which is the decision. And so we compare our p-value here of 0.1586, we compare that to alpha. Okay, now in this case, we're dealing with 90% level of confidence. Okay, so they didn't tell us what alpha was, but we have that formula, 1 minus c, so in this case 1 minus 0.9, which is 0.1. Okay, and so what you'll notice here is that 0.515 is more than 0.1. Okay, so this is a fail to reject the null hypothesis. Okay, and we'll deal with the conclusion in just a second. Okay, now what I want to show you is the alternative to this is how to deal with the rejection region approach. Okay, well, we know this is two-tailed, right? So that means I'm going to have a negative z alpha over 2. And the reason it's z alpha over 2 is because that alpha is split in half, two areas, okay? So as a result, our rejection region is going to be what I'm highlighting in blue. So if we can get our test statistic to fall in there, we're in good shape. Okay, now what I need to know then is what the critical value is. So I need that table once again, unless you remember them. So let's go back. So we're dealing with 90%, and so that value is going to be right here, 1.645. Okay, no problem. Let's go back. Okay, and so let me maybe put it in another color so it's easier to see. So this should be 1.645, and this one, negative 1.645. Okay, well, we have to remember what our particular test statistic was, and that was negative 1.41. Well, that, guys, is going to land somewhere over here, right? It's not in the rejection region. Okay, so from this view, we also see that this is fail to reject the null hypothesis. Okay, so again, another approach to using this particular test statistic did not fall within the rejection region, so it is a fail to reject. Remember, we need it to fall either greater than 1.645 or less than negative 1.645. So be careful with your negative numbers. Okay, either way we spin it, we have a conclusion to write. Okay, so the conclusion is I always have a tendency to combine the words at and the, and I don't know why I do that, but anyway. At the alpha equals 0.1 level of significance, okay, we do not have enough evidence to support the claim by the global watch group. And that's it. Okay. So once again, this video wraps up two examples. It shows you our hypothesis test using p-values, as well as hypothesis tests using this new method, which deals with rejection regions. And so hopefully you've got these two alternatives in it, and it helps you understand this level of significance a little bit more in depth.